record. All right, guys. So we're going to go ahead and get started with this function right here, log base 2. That's log, okay? Log base 2 of x minus 5. We need to find the domain of this function. Now, guys, remember the domain of the log function is restricted to all x's greater than 0. As in, you can only plug in positive values for x. You cannot take the log base of 0. You cannot take the log base of a negative. It has to be the log base of a positive value. So therefore, if you're given a problem such as this, you would go ahead and take the argument right here, set it greater than 0, and then you want to solve this for x. And this will produce the domain of this function. So the domain of this log function would include all x's greater than 5. And of course, when you're writing the domain, you have to write it in an invertation. So this would be -5, comma, positive infinity. Oh, Shazam, why am I putting in, what? Where did negative come from? Okay, there we go. 5 up to positive infinity. There's a question like that on the test. And I guarantee you guys, there's a question like that on the final exam, right? So you need to be able to figure out the domain of these functions, all right? So here's another one. Now this one is a little bit more involved. And this next one is f of x. You know, I was supposed to do a word problem with you guys last time, and I don't know if it was the time before or last class, but I completely forgot about it. Natural log of x squared minus x minus 2. We got to find the domain. So guys, once again, in order to find the domain, you got to take the argument, set it greater than 0, because remember, the domain of these logs, log, the natural log, same thing. Remember, the natural log is just log with base e. So the domain must be all x's greater than 0, everything greater than 0. So for this one, we're going to factor it. Now, this is a quadratic. That's why I'm factoring it, guys. This is going to produce the critical values or the boundary values. So the critical values or the boundary values will be x equals to 2, x equals to -1. Now you want to go to the number line and you want to plot these values on the number line to find which region or regions contain the values that will make the original problem true, okay? Remember guys, whenever you're taking the natural log or the log of a number, this value right here, the argument must be positive. So which region or regions would ensure that you have a positive value for the argument? All right, so now we're gonna test with the 0, guys. Of course, 0 is the best thing to test with. I can hear some of you right now where you're saying, oh, wait a minute, I thought 0 couldn't be part of the domain. You're absolutely right. We're just testing the 0 because it's in the region between -1 and 2. So if we take the 0, guys, we substitute that in. We have f of 0 equals to natural log of 0 squared minus 0 minus 2. All of this simplifies to natural log of -2. Can we take the natural log of a negative? Absolutely not. So this entire region right here would be false. So that would make the region to the right of the 2 true, and the region to the left true as well. Remember, the truth values are alternating. Now, let's say you're not sure which region is still true. Which region contains all the x values that will make the problem true? Try something else, guys. Plug in something else. I'm going to plug in 3. I'm going to plug in a -2 over here. If I do f of 3, I get natural log of 3 squared minus 3 minus 2. Now, 3 squared is 9. 9 minus 3 is 6. 6 minus 2 is 4. Look at that. I can take the natural log of 4. So yes, this checks out. And then I'm going to go over here and do the -2. If I do natural log of -2, there's another parenthesis here, squared minus -2 minus 2. Let's think about this. -2 squared is 4. 4 minus a -2 becomes 6. 6 minus 2 gives me another natural log 4. Okay, so you see the function here is true for both positive 3 and negative 2. The negative 2 is in this region, so every single value in this region will make the problem true. The positive 3 is in this region, so that means that every value in this region will make the problem true. Now, of course, you have to write this in interval notation. So in interval notation, guys, this would be basically negative infinity up to negative 1, not included, union from positive 2 up to positive infinity. And there you are. Questions, guys? No, nothing? Okay, you guys sound like you're a little sleepy, but this is my last session with you guys for the week. I've got one more session with you all on Tuesday, and then on Thursday we take the exam. All right, guys. So I hope you guys have your calculators close by, because I'm going to do a couple of word problems before I move on to lesson 4.3 and then 4.4. This one might be a bit of a longer session, guys, but we'll try and get through it. Let me see here. Where's my word problem that I wanted to do first with you guys? Well, I guess not. So let's do this one right here, guys. So here's a function which determines the percentage of adult height attained by a girl who is X years old. And so the formula is f of x equals to 62 plus 35 times log of x minus 4. Now for this one right here, x represents the girl's age from 5 to 15, from 5 to 15. That's the age, from 5 to 15. So the first question says, approximately what percentage of her adult height has a girl attain at age 13? So if a girl is age 13, what percent of her adult height has she attained by age 13? Now, for this one right here, you would take that 13, plug it into the function, guys. So you would do f of 13 is equal to 62 plus 35. Get those calculators booted up, guys. Times, this is multiplication right here, log 13 minus 4. So on your calculator, you do 62 plus 35 times log of 9. Okay, somebody go ahead and type this into the calculator. Remember, this is going to turn out to be a percent. Please do it for me, please.
At 97.9%.
So 97.9%.
Well,
huh?
It was 98%. Okay, that's fine now.
Okay.
It just rounds up to 98%.
Round to the nearest 2. So you're good. All right, guys, listen. By age 13, a young lady has attained 97.9% of her adult height. Why? Because young ladies, they stop growing around age 15. And so here's, let's go ahead and do this one right here. At 15, how much of a young lady's adult height has she attained? Yeah.
The equation is 62 plus 35 times log 9?
62 plus 35 times log 9.
Oh, then it's 35.3.
What? The answer?
Oh, 95.3, sorry, 95.3.
95? Oh, you gave me the wrong thing?
Yeah, because I thought it was plus. I thought it was
It is a plus sign right here.
No, the second one. I thought the second one was also a plus.
No, that's multiplication, man. That's a dot. What'd you get? 93.1?
95.3.
95.3. Okay. Let's do better with the second one then, okay? What about at age 15, guys? At age 15, we would go ahead and substitute 15 in for x. Now, you guys can always go back in your calculators and just edit out that one number because you're using the same formula over again. So it'll be 62 plus 35 times log 15 minus 4, which would give you 11. Guys, go ahead and plug that in there for me.
98.4.
98.4?
Yeah.
98.4% of her adult height. So in other words, at 15, most of you young ladies will have attained your adult height. So the height you currently are, which is everybody in here, I think that all of you are over age 15. Anybody younger than 15? Pretty much that's the height you're going to stay at for the rest of your life. Okay? Now, it's not the same thing for the guys. The guys can keep growing until about age 21. Yeah. All right, guys. So that was one of the word problems. Now I'm going to move on to lesson 4.3. Okay, we're looking at properties to expand or condense the logs. All right, so guys, make sure you're asking questions if you don't get this. And remember, by the way, this last question I just did, there's a few word problems on the test. By the way, the test has quite a few word problems. I think it has 8 word problems in there, okay? Some of them, they're super easy. They look intimidating, but they're super easy. Like this last one we just did, that was just plug it in and put it on your calculator. So many of them on the test are like that, guys, where you plug in the value, put it on your calculator, get the corresponding output. So those are easy. All right. So guys, the 3 properties we're focusing on are the product property, the quotient property, and then the power property. Now, sometimes I like to use the acronym PQP properties, okay? This all goes back to exponents. Remember, the logs are the exponents of, the inverse of the exponents, inverse of the exponential function. So guys, think about the properties we use for exponents, like the product property. The product property, when we talked about the basic rules of exponents, was if you're multiplying with the same base, what did you do with the powers? You kept the base and added the power. So it's the same thing here. So for the product property, basically says this: if you have log base b of the product of m times n, you can take this and extend it, we're expanding right now, to log base b of m plus log base b of n. In other words, the product becomes a sum. The product becomes a sum when you expand this. And you can also do this in reverse. If you are given the sum, you can condense the sum into a product, okay? So you could go vice versa on this. So what in the world am I talking about? Let me give you a couple of examples, guys. So let's say you have log 100x, and they want you to use the properties of logs to expand this. So when you expand this, because this is 100 times x, it will become log 100 plus log x. Now, that's, oh, Shazam. Okay, this is really messed up. Okay, guys. So if you can simplify a log, you must simplify it. That log 100, you can plug it into your calculator, but you need to simplify that, guys. Does anybody know what log 100 simplifies to? Anybody? David, I haven't heard from you today.
2.
2. All right. Some of you sound very sleepy. All right, guys. So there you go. 2 plus log x. That would be your answer, okay? If you can simplify a log, you must simplify it. Now, if you're asking, how did we get 2? Basically, this is saying 10 to the what power gives you 100, and that's 2. Okay? So here comes another little one. Number 2. So let's say we have natural log of, let's see here. I'm just making this up as I go along, guys. EX, natural log of E times X. You can take this and break it up into natural log E plus natural log X. What does natural log E simplify to? And yes, you can plug that into your calculator. What does natural log E simplify to?
1.
Anybody?
Is it
Plug it into your
1?
calculator. What do we get? 1. Very good, Megan. So this would be your answer, guys. Be careful with these, okay? They are in the test as well, obviously, on the assignment. All right. Hold on a second. I'm letting somebody in. And I don't know why this thing takes so long. I keep clicking on the name, but it's not coming in. Oh, there we go. Awesome. Okay, guys. So here's the next property, the quotient property. Now, the quotient property, again, think about it in terms of the exponents. When we talked about the rules of exponent, we talked about dividing with the same base. Pretty much you kept the base and subtracted the powers. So it's essentially the same thing here, guys, when we're dealing with the logs. So on this one, if you were given log base b of m over n, as in m divided by n, the quotient of m and n, you can take this and expand it to log base b of m minus log base b of n. So in other words, that quotient becomes a difference. It becomes subtraction. So addition becomes, multiplication becomes addition, and division becomes subtraction. So here, guys, you can also do these in reverse. So the quotient becomes a difference, and you can go vice versa. If you are given a difference, you can condense that to a quotient. Now, be careful when you are doing these on My Math Lab. Okay, guys, so here comes a couple of examples. Let's say I have natural log base. Ooh, Shazam, there's no base on the natural log. What in the world? I was going for log. Okay, I'll do this one right here. Natural log of E. Natural log of E over X. Now, the E is dividing X. So we can expand this to natural log of E minus natural log X. So now you can simplify the natural log E to 1, and you're left with the natural log X, because you can't do anything else with that. So that's it. Number 2, what if we have log base 2 of y over 8? On this one right here, when we expand it, we're going to expand it to log base 2 of y minus log base 2 of 8. So now the log base 2 of 8, you can simplify it. 2 to the what power gives you 8? Anybody know? What's log base 2 of 8, guys?
3.
Come on, guys, you can do this.
3.
Good morning, Taina. Ooh, Taina, are you there? I thought I let you in. Oh, you are there. Well, good morning, Taina. Okay.
Good morning.
-3. Okay, guys, so once again, when it comes to expanding the logs, if you can simplify a log, you must simplify it. And that's it for the quotient property. Now, I am going to be going through some examples. When I go through the examples, do you guys want me to go through the assignment, or do you want me to just do some examples from the textbook? Okay, you guys have to let me know. Okay, how about this? Give me a thumbs up if you want me to go through the assignment. No thumbs up. 1 thumbs up by David. And that's it? So the rest of you don't care? Okay. Oh, there's 2. I need a majority. How many of you are in this room right now? Apparently 7 of you. So, there's 3. I need 1 more. Okay, so that's it. So I'm just gonna do, okay, since I didn't get 1 more. All right, guys. So here we go. The power properties next, guys. For the power property, it says this. If you are given log base b, why is this not writing here? Log base b of m to the p power. This power here will become the coefficient of the log. So then we can rewrite this as the power times log base b of m. So in other words, the power becomes a coefficient. The power becomes a coefficient. So what in the world am I talking about? I'm going to give you guys some really good examples from the properties we saw last class. One of the properties was this. Natural log e is equal to x. Now, why did natural log e to the x become just x? Here's why. That's a power. The power becomes the coefficient of the natural log. So you can rewrite this x times natural log e. And everybody knows natural log e cancels out to 1. So that just leaves you with x. Here's another one, number 2. Log 10 to the x is equal to x. Why is that? Because here the power becomes the coefficient of the log. So this would be x times log 10. And log 10 simplifies to 1. So that just leaves you with x. One more. Log base 2 of 2 to the x power. Now this x power here becomes the coefficient of the log. So you can rewrite this as x times log base 2 of 2. So log base 2 of 2 simplifies to 1 because 2 to the what power gives you 2? 1. So this simplifies to x. So that's how the power property works, guys. Now, those are the 3 properties that we use to condense as well as expand the log. These guys are not difficult. However, they are very tedious, especially when you're having to type these answers into my math lab. So what I'm going to do now is go to one of the quizzes, okay? This one is going to be quiz number 14. And I am going to take some questions directly from there. So it is being recorded. You can always go back over the recording later on, guys. But I would go ahead and take some really good notes on this. Or you guys can even multitask since you're on a computer right now. Is anybody on their cell phones? No? Okay, that's fine. Whatever. Okay? So since you're on your computer, you can actually do this with me as I go through the problems. I'm in quiz 14, lesson 4.3, guys. Quiz 14. Oh, I forgot to record the number for the attendance. Anybody remembers the number for attendance? I can go back and get it too.
I think 7193.
7193. Let me type it in the chat box. By the way, everybody, I had a chance to speak to the CEO. Well, I went into a webinar with the CEO, and I did ask him a question. My question wasn't very deep, but the students from yesterday, they were concerned about 7143, Evans. What was the number again?
I think it was 7193.
7193. That's the attendance code, guys. Okay. So anyway, some of the students were concerned about the emoticons on here, how we only have 2 options. So they wanted to know if we could get some additional emoticons. The class that I surveyed yesterday said, how about we get ones like mind blown, the light bulb, the confused look, you know, the monocle one. okay, to show somebody who's really, really smart. And so I asked the question, and the CEO actually answered my question, although it wasn't a really positive answer. He's like, listen, we're all about security right now. We're not going to change any of these emoticons, okay? So he has these webinars every Wednesday where he comes on with his team and answers questions from the public. All right, guys, so here we go. I am in quiz number 14, and hopefully you guys are booted up. I'm starting with number 1, log base 7 of 7 over y. You have to expand this. So when you expand this, it becomes log base 7 of 7 minus log base 7 of y. Log base 7 of 7 simplifies to 1. So here's your answer. By the way, guys, when you're typing this into My Math Lab, there is a subscript option on the tools palette. It's like the one next to the parentheses when you're ready to type in your answer, okay? So make sure you use that subscript. Next one, number 2. It is log 10y. This is multiplication, so we can extend this to log 10 plus, because multiplication becomes addition, log y. Log 10 can simplify to 1, so this would be your answer. All right, guys. Number 3. For number 3, natural log of 4th root of x. Now, for this particular problem right here, most of the time, okay, when you encounter the radicals, guys, you have to convert them to a fraction or exponent. So this one right here would be natural log of x raised to the 1/4 power. So now you have a power. Remember the rule, the powers become coefficients of the log. So the answer for this one would be 1/4 natural log x. Okay, I'm pausing here because I want to see if you guys have any questions for me before I move on to the next part, because this one right here has 2 properties. Any questions? Here comes Lily. Okay. All right. Nope, not coming in. Come on, Lily. All right, there we go. No questions, guys? You can raise your hand, you can just ask a question, you can type your questions in the message box. It's up to you. Nothing? Okay. By the way, I will be creating a DNC for you guys for the final exam. All right, guys, so pay attention. Here it comes. We are going to expand this. There are 2 properties here. First, the quotient property. Division becomes subtraction. Plus, we got a radical here. The radical will become a fraction or exponent like this one up here, okay? And the fraction or exponent becomes a coefficient. So I'm going to rewrite it out. Log base 5, z to the 1/2. Where did the 1/2 come from? That's the square root. Minus, why do I have the subtraction? Because division becomes subtraction. Log base 5 of 125. Guys, I just realized I didn't show you how to plug these into the calculator, so I'm going to have to take a pause here and show you how to do it on the calculator. Let me finish this part right here. The exponent becomes a coefficient. So this would be 1/2 log base 5 of z. Now, we need to simplify this. Log base 5 of 125. Now, you can do this on any calculator. First, let me address how you do it on any calculator. To do this on a calculator, to simplify that, guys, we're going to do a change of base. We're going to take the log base 5 of 125 and rewrite it without a base. By the way, guys, if you have a log with no base, what is the base?
10.
10.
10. Very good. So I just took log base 5 of 125 and rewrote it as log 125 over log 5. By the way, guys, when you hit the log, the parentheses will automatically populate. And you want to make sure you close the parentheses in the numerator, close the parentheses in the denominator. Any of your calculators. So if you have your calculator in front of you, give it a try and see what it gives you. Now, having said that, what is happening? How is the calculator calculating this, computing it? So pretty much in the numerator, it's saying 10 to the watt power, because there's no base here, the base is understood to be base 10. 10 to the watt power gives you 125. Okay, so that would be 2 point something. And then in the denominator, 10 to the watt power gives you 5. So that would be a decimal, okay? So now, guys, they take the two answers, the one in the numerator, the one in the denominator, they simplify them, they divide them, and that's how they come out with the answer for log base 5 of 125, okay? So what's the answer, guys? Log base 5 of 125.
3.
What's the answer? 3. Very good. Okay, so that is how you do these on the calculator. Now, that's any calculator. Those of you who have the TI-84, and I think, Megan, you have a TI-84, it's even easier for you, Megan, okay? So what I want you to do, Megan, is go under the math menu, although I never remember where it's at. Okay, go under the math menu, Megan. Now, scroll down the first list and see if you see anything that says log base. You see it? No? Oh, you do? Okay, perfect. Hit and, oh, no? Okay. Move over to num at the top. You should find it under num then. Scroll through the list and find something that says log base. So once you see it, hit enter. Did you find it? What, Megan? What in the world? It's in your calculator, I know that. Okay, can you turn on your camera and so I can look at your calculator screen, because I don't have my calculator with me. I do it with you guys, but I don't have my calculator with me. Okay, now hit the math button, Megan. Hit your math button. Okay, tell me what, okay, so I can't see any of that. All right, tell me what you see on the menu, in the math menu. And it's usually like option 0 or something. You have to scroll down the list. Keep scrolling. Do you see anything that says log?
There's nothing.
There's nothing that says log?
No.
Okay, so then go to the top and move over to num. Okay, now scroll down through the list. Do you see it?
There's nothing on that one either.
What the heck? Where's your log base? Really?
Yeah, there's nothing on here.
Okay, who else has a graphing calculator on here? Because that is where you find the log
I do,
base.
but it's a TI-83. It doesn't have it.
Okay, yours is on older version, Evans. It doesn't have it, but on the newer version, it should have had it. Maybe yours doesn't have it either. Like what do you have, an 83 or an 84, Megan?
I have a TI-84 plus silver edition.
Oh no, that has it. Okay, do me a favor and play around with it.
Okay.
I know it's in the math menu somewhere. Okay. Well, since you're the only one that's being affected by it, I'm going to move on, but I'm going to have to find this before the end. Well, even if it's the end, we're going to figure out where the log button is. I know it's under the math menu, guys. Okay. So we'll figure it out after class. All right. Now, guys, let me go ahead and move on and save that for later. But let me just say this. When you have the log base on your calculator and you hit that log button, Megan, keep playing around with it and see if you can find it, because I know it's in there somewhere. Okay?
Okay.
When you pop it in, when you hit enter on the log, this is what it's going to look like. So essentially, it's set up for you to go ahead and plug in your base. In the case of log base 5 of 125, you would type in your 5 as the subscript, your 125 right here, and then hit enter. It is that easy on the newer versions of the graphing calculator. So if you got a newer version of the graphing calculator, guys, this is a piece of cake. All right. So now, everybody, I am going to continue with the assignment. Let me go ahead and grab some additional problems. We have, hold on a second, I went to the wrong thing. We have one more lesson to do, and then we'll be done. Okay, number 5, guys. I'm not gonna do everything, by the way, in the assignment. Number 5, this one is a little longer. This one is applying all 3 properties, x to the 3rd times y over z to the 4th. All right, so we got multiplication, we got division, then we got the powers in there. So when we expand this one, it's going to be log base b of x cubed plus log base b of y minus log base b of z to the 4th power. Now, this power here is going to become the coefficient. This power will also become a coefficient. So the final answer for this one, guys, will be 3 times log base b of x plus log base b of y minus 4 times log base b of z. That's what you have to type on the computer, guys. Okay? We're good? All right. Now, here comes the next one, number 6. We're now moving into condensing the logs. So the first one says log 2 plus log 5. You can actually type this into your calculator, log 2 plus log 5. But if we're using the properties to condense this, we are adding, addition becomes multiplication when you do this in reverse. So you're going to keep the log and multiply the 2 arguments together, 2 times 5. And 2 times 5 gives you 10. What's log 10 simplified to, guys? What does log 10 simplify to?
1.
1. Just like that, you're done. Okay, next one, guys. This one is number 7. We've got log base 3 of 45 minus log base 3 of 5. So on this one, we have subtraction. Subtraction becomes division. So we can rewrite this as log base 3 of 45 divided by 5. Now, 45 divided by 5 simplifies to 9. So now you got to figure out the value of log base 3 of 9. What's log base 3 of 9, guys?
2.
2. That's it. Number 8. This is another one where you have to condense it. Log y plus 12. Ooh, there's a 12 in there. Let's erase that. Okay. Plus 12 times log z. Okay. So you got 2 properties in there. The addition becomes multiplication. Then you've got a coefficient here, which will become an exponent, a power on the z, on the argument of the second log. So when you condense this, guys, you're going to condense it into a single log base. And in the parentheses, which represents the argument, you'll have y multiplied by z raised to the 12th power. Any questions? You guys good? All right, guys, I'm not hearing any questions. I'm a little concerned. Okay, sounds like you guys are thinking this is easy. So I am going to move on to the next one, or maybe you're just not awake yet. Shazam. All right, guys, here's one for you to consider, as in think about it and tell me what you think. This one is number 10. I skipped over number 9 because it's easy. Number 10, log base 4 of 2x to the 3rd equals to 3 times log base 4 of 2x. The question is this true or is this false? Is this statement true or is this statement false? What do you guys think? Is log base 4 of 2x to the third equal to 3 times log base 4 of 2x? True or false? Are these two statements here equivalent to each other? What do you guys think? Come on, guys, speak to me. Now, as I've always said, if we had to go to the school site, all of you guys would be awake by now. I'm surprised you guys are not awake yet. All righty, guys. So, nobody? Oh, Megan says false. Only Megan answered. Okay. Well, let's check it out, guys. Megan says false. Look at the right side, guys, where we have a coefficient of the log. So that coefficient is going to become a power on the argument. So you can rewrite this as log base 4 of 2x to the third power. So essentially, this is asking us, is 2x to the third the same thing as 2x raised to the third power? Are these two the same thing? No, they're not. Because here you just have 2x to the third, but here you have 2x raised to the third, as in 2x times 2x times 2x. So when you do this, you get 8x to the third. So as you can tell, they're not the same. So therefore, this one is a false statement. How you doing, guys? We're good? Okay. So now I am going to move into lesson 4, guys. And lesson 4 is where the majority of the work comes from. So I need you to pay careful attention because you're going to see many of these problems on the test. All right. So we're moving into lesson. You know, I have a word problem for you guys. I think I forgot to do the word problem. Shazam. Okay, hold on, guys. I may have to go back and grab this word problem with you all. Hold on. Oh, it's actually in the next lesson. Okay. Well, that's fine. Oh, yeah. Okay. All right, guys. Lesson 4.3. And in lesson 4.3, this is where we're solving things. I said 4.3, 4.4. We're solving exponential and logarithmic equations. Solving exponential and logarithmic equations. All right, guys. So the first type I'm going to talk about are the ones where you can factor these using the same base. So I'm going to talk about the 1, 2, 1 property first. And the 1 to 1 property basically says this. If you have b to the m is equal to b to the n, in other words, if the bases are equivalent, then this means that the powers are equivalent to each other. So for these problems where you can factor the bases into like bases, guys, here's how you're going to do them. Okay, so number 1, you want to factor the bases, if possible, into like bases. So you have the same base on both sides. Number 2, once you have the bases factored into like bases, set the powers equal to each other. Set the powers equal to each other and solve it. Guys, this one's easy. Very, very easy. So I'm still in quiz 14. I am going to get started with number 11 for the examples, okay? Because I don't want to go ahead and do an example that's not relevant to the assignment. So I'm going straight into the assignment, okay? I'm still in quiz 14, guys. So this one is 4 to the 4x minus 6 is equal to 16. Now, I can take that 16 and factor it to 4 to the second. So since the bases are equivalent to each other, that makes the powers equivalent to each other. Remember, guys, this is an equation. This is all about balancing the equation, as in you want to have the exact same thing on both sides. So to make sure that you have the exact same thing on both sides, the bases must be equal, the powers must be equal. So set these equal to each other and then solve. You add 6 to both sides. So you get 4x is equal to 8. So obviously, x will equal to 2. So the value that would ensure both sides of this equation are equal to each other would be 2. All right, guys. Here's another one. This next one right here, I have 27 to the x power is equal to 81. We can go ahead and factor 27 to a base 3 number, factor the 81 to a base 3 number as well. 27 is 3 to the 3rd power. 81 is 3 to the 4th power. Since the bases are equivalent, that makes the powers equivalent to each other. And then you solve this, so you get x is equal to 4/3. There you go, guys. Now, let me just pause and say this here for some of you who may not be thinking about this yet. If this was a multiple choice question, even if it wasn't a multiple choice question, guys, you can use some good old-fashioned common sense and try to figure out approximately where the answer is going to be. Because you know 27 to the 1st power is going to be 27. And if you do 27 to the 2nd power, that's going to give you a very large number, okay? Around the 800s. Okay, so you know the answer is going to be consolidated in between 1 and 2. So you know you got that little approximation going on in there. So use some good old-fashioned common sense, guys, okay? Here comes the next problem, which is number 13. Now, for number 13, guys, this one is 8 to the x minus 3 over 6 is equal to the square root of 8. Now, the bases are both 8. But, guys, if you look carefully, there's no power on the right. So how do we get the power on there? Well, we're going to have to change that radical, the square root, to the 1/2 power. Remember, for the majority of the time when you're working on these problems in the log section, you're going to have to convert your radicals to fractional exponents. So now, guys, we have equal bases, which means the exponents are equivalent to each other. So this is the equation that results. And now you're going to solve it by multiplying both sides by 6. So the 6's cancel out here, leaving you with x minus 3. And then if you do 6 times 1/2, that's going to give you 2. And then you, oh, Shazam, that's 3. Ooh, shame on me. Anyways, so now we're going to go ahead and add 3 to both sides. So you get x equals 2, 6. Now, the last step I should have put on the steps was to set them equal to each other and to check the solution. But I did not do that. Just remember, guys, sometimes even when you're sure, especially on a test, plug the answer back in and see if it makes sense within the context of the problem. All right, here comes the next one. Now, guys, this one is a bit difficult. It's challenging. And I'm going to show you why this one is a challenging problem. I have another conference at 10. When is the next test? Well, it's opening up at 11. And so, ooh, did you leave already, Erin? Yeah, she left. I didn't see that. Okay. All right. Okay, who just came in? Okay, I think somebody just came in, but I'm not sure who just came in. All right, guys. So here we go. On this one, Oh, yeah, I understand. I understand. All right, guys. So after next Thursday, you can sleep as long as you want to, okay? So guys, here we go. On this one, here's why it's challenging. When you factor the 81 into a base 9, it becomes 9 squared. Now, there was already a power there. That power must be enclosed inside a set of parentheses. If you do not enclose it inside the parentheses, it will lead to the wrong solution. So make sure you enclose this inside a set of parentheses, guys. Just be careful, okay? So now you take the powers and you set them equal to each other to solve this. You get x plus 3 is equal to 2x minus 18. I would subtract x from both sides. So I get 3 is equal to x minus 18. Add the 18 to both sides. So guys, here is the answer, 21. Okay, you guys are definitely sleepy today. Nobody's asking any questions. By the way, Elizabeth, obviously we are recording this, so whatever you miss, you can always look it up on the recording. And I did send out all the YouTube links to you guys. So today, once I'm done with the session, I'm gonna upload the video to YouTube again and get the link and send it out to you as with the rest of them. And so you won't be missing out on anything. Now guys, 1 over e, that's a fraction. What do the fractions indicate? A negative exponent. So this would represent e to the negative 1 power. Since the bases are equal, that makes the powers equal to each other. By the way, this is number 15 and quiz number 14. You subtract 5 from both sides. And so this would give you x equals to negative 6. Okay, so if you plug in that negative 6 in for x, you'll get e to the negative 1 power, which is the same thing as 1 over e. And guys, that's it for quiz 15. So now, quiz 14. Now I am going to move on to quiz 15. And at the beginning of quiz 15, we also have some of these type of problems where you have to factor the bases into like bases, okay? There's another way to do this, but this is the least complicated way to do these problems. All right, guys. So I'm in quiz 15 right now, okay? And I'm starting with number 1. And for this one right here, I have 4 to the x plus 1 is equal to 32 to the x minus 5. Now, for this one right here, you cannot factor 32 into a base 4, but you can factor it to a base 2, and then that means that you have to factor 4 into a base 2 as well. So 4 would be 2 squared, and 32 would be 2 to the 5th. And now, guys, the bases are equivalent. That makes the powers equivalent to each other. And then you solve this. You guys go ahead and give this one a try and give me the answer. Now, guys, listen, use the notes. Don't make this complicated. When you go on My Math Lab to do the assignment, they may want you to use the logs, but if you can factor the bases into like bases, you do not have to use the logs. The only time you have to use the logs or natural log is when you cannot factor the bases into like bases, which is the next type of problems that are coming up, okay? All right, you guys are good? Okay, so moving along, what'd you guys get for the answer?
X equals 9.
X equals to 9. Megan said that, Ashley said that, very good. Should I go over it? David, do you want me to go over it? No? Okay, so let's distribute the 2 guys. We get 2x plus 2. Distribute the 5, we get 5x minus 25. Now we're going to subtract 2x on both sides. So these cancel out, leaving us with 2 equals to 3x minus 25. Now add 25 to both sides. So you get 27 is equal to 3x. So therefore, x is equal to 7. Oh, Shazam, 9. What am I talking about 7 for? 9. All right, guys. So now I am going to move on to the next part of this, part 2. When you are going to be solving exponential equations, using the logs. All right, guys. Now, what in the world am I talking about? Let's say we have a problem like this, guys. 3 to the x is equal to 17. We cannot factor 17 into a base 3. However, we can narrow down where we think the answer is going to be and between what two whole numbers. Why? Because we know 3 squared is 9, and we know 3 to the third is 27. Furthermore, 17 is in between 9 and 27, so therefore the answer would be in between 2 and 3. So now your job is to figure out what decimal approximation would you raise 3 to get to 17. So in order to do this, guys, especially since you have your variable and the power, you have to use the log to solve it. Now, for these problems, the first step is to go ahead and isolate the exponential term, whatever that exponential term is. Once you have the exponential term isolated, number 2, you want to take the log here. Actually, I'm going to say it this way instead. Take the natural log, which is the same thing as the log of both sides. Now, here's why I say natural log first, because in this textbook, they want you to use the natural log to solve these problems, not log. So you want to take the natural log of both sides. By the way, it doesn't matter if you use the natural log or log, you will get the exact same answer. The only time it really matters is if you have an E base, you must use natural log, okay? If you have a base 10, you must use log, all right? So guys, for this, you take the natural log of both sides. Number 3, you're going to apply the properties of logs. If possible, I'm trying to write apply here, Shazam, okay? Here, how about this? Okay, guys, I'm being lazy right now. Use the properties of logs, use the properties of logs. And when you use the properties of logs, most of the time it is changing that exponent to a coefficient. And in step 4, you're going to now solve the problem. Okay, guys. So going back to our little conundrum here, 3 to the x equals to 17. The exponential term is already isolated, so the next step is to go ahead and take the natural log of both sides. So you take the natural log of 3 to the x, natural log of 17. Now, the power here, the x, becomes the coefficient. That's where we're applying the rules, the properties of logs. So this becomes x times natural log 3 is equal to natural log 17. Now remember, we're solving this for x. So the last step is to go ahead and divide both sides by natural log 3. By the way, guys, I'm going to need you to boot up your calculators for me, please. Okay. Hold up a second. Elizabeth, do you have a calculator? X natural log. You have a graphing calculator? X natural log 3 equals to natural log 17. So we divide both sides by natural log 3, guys. So listen to this part, guys. On the assignments, they want two forms of the answer. They want the answer expressed in terms of the natural log. So this is one way. And then they want the decimal approximation. For you to get the decimal approximation, you grab your calculator and you're going to do natural log of 17 divided by natural log of 3 and plug this into your calculator, guys. The attendance code is 7193, Elizabeth. Okay, somebody plug that into a calculator for me, please. Natural log 17 divided by natural log 3. And guys, you all should practice with that to make sure you know how to plug this into your calculator and ensure you're getting the correct answer. So please plug it in for me. What you guys got? 2.57. Thank you, Megan. 2.57. So when you guys are in my math lab, they're going to ask you for both the answers, okay? Next. For these particular problems, guys, listen. When you are working on them on the computer, be careful with the rounding because sometimes the computer wants you to round it to a certain decimal place. So in the case of these, they want you to round them to 2 decimal places. The thing is 100. All right, so I'm going back into the assignment. I'm grabbing problem number 2. 7 to the x is equal to 71. And guys, once again, this is quiz 15. Oh my God, I'm trying to write 71 right here. Why won't this thing cooperate with me? Oh, I have a crack on my tablet right there. That's why. 71. All right, guys. This is the exponential term. It's already isolated. So I'm going to take the natural log of those sides. The exponent becomes a coefficient. So we added x times natural log 7 is equal to natural log 71. Now we divide both sides by natural log 7. So if you were writing the answer in terms of the natural log, it would be natural log 71 over natural log 7, and you're done. Now, they may want a decimal approximation, so you would grab your calculator, type this into the calculator to get the decimal approximation, guys. Give it a try, please. Okay, you guys are not doing it. I don't have my calculator in front of me. Ooh, Megan just gave it to me. All right, Megan, 2.19. Thank you, Megan. All right, guys, next one. On this one right here, we have 7, another 7, e to the x is equal to 53. Now, for this one right here, guys, e to the x is the exponential term. So we want to isolate it by dividing both sides by 7. So the 7's cancel out, leaving you with e to the x equals to 53 over 7. Now, take the natural log of those sides. There's that natural log e in there, guys. So x, we apply the property of logs, becomes a coefficient. So you have x times natural log e equals to natural log of 53 over 7. So essentially, this cancels out to 1. So you're just left with natural log of 53 over 7. And you guys would go ahead and type this into your calculator and get the answer for it. Guys, try typing it on the calculator.
2.02.
3.02. Awesome.
2.02.
0.02?
2.02.
2.02.
Yeah.
Okay, now guys, you can always check these. If I do 7 times e to the 2.02, is that going to give me a number that is close to 53? So if it's a multiple choice test, you can always plug and check these, okay? Now, let's keep going. Guys, I wonder what they're gonna do. Did you guys get your scores from the SAT? No?
Yeah, we got those back in March 20 something.
How'd you guys do?
Better than last time.
Better. Oh, that's awesome.
Got an 1190.
That's great.
No
you know what that? Well, no. Wait a minute. Didn't
You
they
want that
increase the
1,200.
requirements for bright futures for you guys? Yeah, they did.
Yeah. I have enough to get a 75% one, not the not the full one.
Yes. Mm-hmm.
I was gonna retake it, but I don't know how that's gonna work out now.
Next year, Sugar Plum, next school year,
guess.
2021. Yeah.
If they
Anybody else care
yes,
to
they said-
share?
they think they're saying like they're only taking scores from 2020 if you graduate in 2021.
Really?
That's what I looked up. They might change it though. I'm not sure.
Because you don't have, because many of you are supposed to be applying for colleges right now. And so you're not going to get an additional opportunity to take these tests. And many colleges, they look at them. So, I think these colleges may have to relax on the requirements to get into their program, whatever program you want to go into. And
'Cause I still
especially in
haven't
the
even
state
taken
of
the
Florida
ACT.
with Bright Futures. What happened?
I still haven't even taken the ACT.
That's
Same.
okay. That's okay. Don't worry about stuff like that, man. You'll be fine. Don't worry about them. Right now, what you need to worry about is you and your family being okay during this time. That doesn't make sense?
No,
It does.
makes perfect sense.
Miss Alcira, always looking on the bright side of things. Shazam. Guys, listen, I'm enjoying being at home, I have to say. Anybody else with me?
I agree.
I mean, if I had my
All
camera
right.
on, you'd just see me in my blanket, so it's pretty relaxing.
Now, come on. Nah, you need to get out and go enjoy this beautiful weather.
It's
No, I
hot.
mean in your
raining.
backyard. Shazam, in your backyard, people. Listen, the way I look at it is this. There are so many people right now that I empathize with, people living in the high rises in New York and Chicago. They can't get out, okay? And some of them are caught up in these apartments with a whole bunch of kids. They're stuck in these places, guys. So we in the state of Florida, for the most part, okay, yes, we have high rises too. However, for the most part, we're living in these single family homes. We have room to breathe, stretch out, especially in our little area here. We can go walking down the street without running into anybody who's going to compromise our health. Okay? So guys, take advantage of it. Enjoy it for somebody else who cannot enjoy it. You see what I mean? Okay, fine. I'm talking.
I suppose so.
Huh?
I suppose so.
One person agrees with me. That's good enough for me. Okay, guys, let's do this one. So we're going to isolate that exponential term. So you get e to the 11x minus 3 is equal to 16,753. Then we take the natural log of both sides. Now this exponent becomes a coefficient, 11x minus 3 times natural log e is equal to natural log of 16,753. Obviously, natural log e cancels out, leaving you with 11x minus 3 equals the natural log of 16,753. Now, guys, we're solving for x. So add 3 to both sides. Be careful. Be careful. Don't add that 3 to the 16,753. No, this is 3. This is natural log of 16,053. And so they're not the same thing. You can't combine them. Now, next, we're going to divide both sides by 11, guys. I'm trying to squeeze it all in here. So the final answer for this one is going to be natural log of 16,753 plus 3 over 11. I want you guys to type this into your calculators to see if you get the correct answer. Now, how you guys doing? All right, let's see. What'd you guys get? Oh, guys, come on now. You got to participate. It's like 10:25 and I still have a whole lot
I
to
got
do. Hmm?
1.15. 1.15.
1.15? Okay. Megan, I'm seeing 88 from you. Let me see. Maybe I went too far. Yeah, 0.88?
0.88.
Okay, so let me type it into my calculator so I can tell you guys exactly what it is. I'm using my phone calculator. I don't really have a calculator. I gotta get a calculator out of that car. Okay, so you get this answer and then divided by 11. So the answer is 1.16. Is that what you guys got?
Yeah.
Okay, Megan, you didn't get that. Okay, so Megan, what I want you to do is the natural log 16,753, close the parentheses, plus 3, hit enter. Once you get that answer, you're going to divide it by 11. And that will ensure the correct answer. And the correct answer for this one, guys, is 1.16. That's the decimal approximation. All right. You guys are good? Did you get it, Megan?
Yeah, I got that. I think the first time it's because I put the 3 in with the natural log.
Ooh, Shazam. Now, the other thing you could have done, Megan, is to put parentheses around the numerator and then divide it by 11. That would work. All right, guys. Now, here's the third type of problems we're going to solve, and we are going to finish class. And that is the log equations. We're going to now solve the log equations, okay? So, number one, guys, we're going to use the properties of logs to condense each side. If possible, sometimes you can. All right, number two. Next, we're going to convert to the equation to an exponential equation. And guys, remember the acronym BAP, the log, base, and to power. Number three, we're going to solve the equation. And guys, and this is critical. Number four, you must check the solutions. Why? Because when you're working with the log, remember the domain is restricted. So check the solutions. Check the solutions. Now, additionally, you will encounter some of these problems involving the one-to-one property of logs. So let me go ahead and show you guys what I mean by that. The one-to-one oh, let me do this. I haven't used this in a while. Way back in chapter 2, I used that. The one-to-one property of log says this, guys. If you have log base b of m equals to log base b of n, then that means m will equal to n. So in other words, guys, if you have the same log bases on both sides and they're equivalent to each other, then the arguments, the m and the n, would be equal to each other, right? So now let's go ahead and practice, okay? Some of these are super easy and then some of them will be a little bit more challenging. Remind me to do the word problems, guys, okay? So this next one is number 5 on quiz 15. It is log base 4 of x equals to 3. This one is super easy. It looks like it's going to range base, that's the answer, and that's the power. That's the acronym I was talking about earlier, BAP. So when we convert this to an exponential equation, guys, it's going to become x, the answer, equals to the base 4 raised to the power of 3. So the answer for this one, 64. That was too easy. Okay, this next one's too easy. Oh, 7 is too easy. Now, let's talk about 8. For number 8, log base 4 of x plus log base 4 of 3x minus 1 equals to 1. Now, on the left side, guys, we can condense that into a single log base. And we have a sum right here. What does the sum become? Multiplication. So when we condense the left side, it'll become log base 4 of x times 3x minus 1 is equal to 1. Now we have condensed the left side. We can convert this to an exponential equation. There's your base, that's the answer, and that's the power. So you're going to do x times 3x minus 1 is equal to 4 to the first power. Now we're going to distribute the x. We get 3x squared minus x equals to 4. Obviously, we have a quadratic, so we're going to go ahead and solve this equation. So guys, let's look. 3x squared minus x, move the 4 over, so it becomes a negative 4 equals to 0. And we're going to factor. For this one, we're going to factor it into 2 binomials, okay? So it's going to be 3x minus 4 times x plus 1. Now, we take each factor, set it equal to 0 and solve. So x will equal to negative 1 or x will equal to 4/3. But wait, there's more. You need to check your solution, guys. You need to take that solution, plug it back into the equation over here, okay? And make sure that the problem makes sense. I just erased some stuff over here. I was looking for the pointer. Make sure the problem makes sense within the context. The answer makes sense within the context of the equation. All right. Obviously, that negative 1 is looking a little sketchy, so let's start testing with the negative 1. So if I were to take negative 1, guys, and I plug it into the equation, look at what I get when I plug in the negative 1. Log base 4 of negative 1 plus log base 4 of negative 4. Can we take the log base 4 of a negative number? What do you guys think? Hello? Nope, we can't. So guys, we must reject the negative 1. So the negative 1 is not a solution. That means that the only solution is 4/3. Now, you can check the 4/3 too, guys, but it works out. For example, if I were to take the 4/3 and plug it in right here, hold on, I'm going to show you. If I plug it in over here, log base 4 of 3 times 4/3 minus 1. I'm doing this one because it's easier, okay? So guys, this one will cancel out, okay? And leaving with log base 4 of 4 minus 1, which is 3. Are you guys with me? Hello? Nobody's with me. Shazam.
I'm with you.
Huh?
I'm still with you.
Okay, thank you, Evans. Now, guys, because this one right here is turning out to be a positive, it's going to work out. I'm just not going to go through the entire process. So the only answer for this one is the 4/3. Now, let me emphasize this, guys. If you are on My Math Lab and you're working on these problems, there are 2 answers and you put both of them in, but one of them doesn't make the problem true, the computer will mark it wrong. You only plug in the value that makes your problem true, okay? So be careful with that. Here's the next one. Log base 3 of x plus 5 minus log base 3 of x minus 3. All right, I'm going to be pausing here so I can ask you guys this question, okay? It's about 10:34 right now, okay? We have a little bit more to go. We haven't talked about the application questions. Ooh, yes, exponential decay, radioactive decay. We haven't chatted about that. So do you guys want to keep going for another like 10 minutes? No, that's still not going to be sufficient. No, I am going to finish this problem right here, guys. And then I'm going to let you go. And then on Tuesday, whatever we didn't finish, we'll go ahead and finish it up, okay? Ask me a question, guys. Nothing? You sure? Okay, so I'm gonna make this the last one, guys. I'm gonna make it the last one. So on this one, we have subtraction. Subtraction becomes division. So we're gonna condense the left side, so it becomes log base 3 of x plus 5 divided by x minus 3 is equal to 2. Now, this one right here, guys, is which number? Let me see. That one is number 9. Number 9. So I'm going to convert this to an exponential equation next. So when I convert this, this is my base, that's my power, this is the answer. So I'm going to get x plus 5 over x minus 3 is equal to 3 to the second. So x plus 5 over x minus 3 equals to 9. Now, I am going to multiply both sides by x minus 3 to solve the problem. So the x minus 3's cancel out, leaving me with x plus 5 is equal to 9x minus 27. And then I need to finish it out, guys. Solve it out, finish it. So on this one right here, I would subtract the x from both sides. I'm just going to go back up to the top because I'm running out of room at the bottom over here. Oh, try this one more time. Okay, guys. So this is what I end up with. This cancels out. I'm left with a 5 on the left is equal to 8x minus 27. I'm going to add the 27 to both sides. So I get 5 plus 27, which gives me a total of 32 is equal to 8x. Divide both sides by 8. So the answer turns out to be 4. There you go. All right, guys. Unfortunately, I am not done with everything because I did not chat about the problems, the application problems. So I am going to table this for Tuesday next week. We are almost done. All right. So what I would suggest you do, rather than during the test over the weekend, I would wait until Tuesday after class is over to go ahead and do the test. Okay, guys? And remember, the test is open until Tuesday night at midnight. So if you don't have any questions for me, I am done, and I will see you on Tuesday. You guys have an awesome weekend. Spend some good quality time with your family, which you're already doing. Okay. Have fun, guys. All right. If you have questions for me, just go ahead and stay after, and I'll answer your questions. All right.
Hi, Mrs. Alcira.
Bye, Elizabeth.
Bye, Miss Elsier.
Bye, Evans.
Bye.
Bye, Megan. Bye. You have a question, Daniel? Hey, Daniel. Oh, shoot.